Okay, today we're going to look at linear inequalities with three sections. We've done linear inequalities in the past that have just got two sections, but this one has got three. So it's got 1 is less than 3x plus 4, which is in turn less than or equal to 13. So the linear inequalities in the past may have not had that part or may not have had that part. Today we're going to look at one with all three parts. So what we're going to do, the first method, I'm going to split it up into two sections. So I'm going to call the first bit 1 is less than 3x plus 4. And the second part, I'm going to take this section here, 3x plus 4 is less than or equal to 13, and solve them as two separate inequalities. So this is good practice at what we've done before. So I'm going to subtract 4 from both sides, so negative 3 is less than 3x. And I'm going to divide through by 3, so negative 1 is less than x. That's that part done. This part here, I'm going to subtract 4 from both sides. 3x is less than or equal to 9. And then divide by 3, x is less than or equal to 3. So you can see that negative 1 is less than x, and x is less than or equal to 3. I can put that all together now, saying x is greater than negative 1 and less than or equal to 3. And I can show that on a number line by marking on negative 1, marking on 3. We'll have an open circle here, and we'll have a shaded circle there. And this line represents the finite range between that's greater than negative 1 and less than or equal to 3. So that's the range in which x can lie. So we can do it in two separate inequalities. But actually, we can do it all at once. And usually we'd actually do that. It's quicker to do it all at once. Usually with equations, we talk about doing the same to both sides. Here we do the same to all three parts. So I've got negative 4 is less than or equal to 5x plus 1, which is less than 31. So remember, the aim is to get x isolated. So the first thing I'm going to do is going to subtract 1. And I'm going to subtract 1 from all three parts of the inequality. So I'm going to have negative 5 is less than or equal to 5x less than 30. Then if I divide through by 5, I get negative 1 is less than or equal to x, which is less than 6. So I've got the solution all at once. It's actually quicker than breaking it up into two, and I think most people will end up doing it this way. I can once again show that on a number line, mark on where negative 1 would be and where 6 is. This is an empty circle this time, and this one is a shaded circle. And I've joined them up with a line, and that shows all the possible values of x greater than or equal to negative 1, but less than 6.